Hello everyone, welcome to the third and the final lecture of concurrency control. In this video lecture, we are going to discuss about the timestamp based protocols for concurrency control. So in our previous two lectures, we have learned how a log based protocol can work for concurrency control and how they ensure the complex serializability of the schedules. We have also learned about the 2PLs and we have seen that the 2PL may suffer from deadlock and starvation. Now in this part we are going to discuss how a timestamp based protocol can handle the concurrency control. So in a timestamp based protocol, basically there are two types of timestamp PCs. The first one is used for each and every transaction. So each and every transaction has its own timestamp. A timestamp can be a unique token value or the time when the transaction is occurring to the processor. As I have told you, the timestamp can be exact time when the transaction is coming to serve or a token value, and the value should be unique. So each and every transaction should have a unique value for a timestamp. The older transaction has a lesser timestamp and the younger transaction has a higher timestamp. Now, a timestamp of a transaction does not change until the transaction has been restarted. So it will remain same throughout the transaction. Now, for some reason, if we need to roll back that transaction, that time the transaction will be restarted with a new timestamp. A timestamp for a transaction Ti will be represented by Ts Ti. So in this point we can write that if Ts Ti is less than Ts Tj, that means Ti is the older process, older transaction, and Tj is the younger transaction. Second type of timestamp is used for each and every data item. Each and every data item maintain two timestamps. One is for read and one is for write. So there is a reading timestamp and a writing timestamp. Reading timestamp will be represented by R underscore TSA and writing timestamp will be represented by W underscore TS A on the data item A. The read and write timestamp for data item A changes during a transaction. So, as we know that the timestamp of a transaction does not change during execution, but the read and write transaction changes in time. At the initial state, the read and the write timestamp for a data item A considered as null. So they start with the null value. Now, as the transaction progresses, the read and write timestamp changes. Read or write timestamp takes the value of transaction timestamp. So how the read and write timestamp will be modified? So read timestamp will be equals to the largest timestamp of the transaction which performed the successful read on A. Suppose transaction 1 having greater timestamp than transaction 2. So transaction 1 is the younger transaction and transaction 2 is the older transaction. Now, if transaction 1 perform a successful read operation on the data item A, then R underscore TS of A will be same timestamp as T1. Similarly, the write timestamp will have the largest timestamp of the transaction which performed a successful write on A. So if that is true, the write timestamp will be this one if the transaction 1 performed a successful write operation on the data item A. Timestamp based protocol always produce a conflict serializable schedule. So it ensures conflict serializability. As it ensures conflict serializability, it will also ensures that the schedule will be view serializable, because we already know each and every conflict serial schedule is a view serializable schedule. But the timestamp based protocol does not say anything about the cascading rollback or the recoverability of the schedules. So we are going to discuss that in a little bit later. So next, The timestamp based protocol checks for conflicting operation depends on the timestamp. Time. So if there is a conflicting operation, it will stop or it will somehow stop the transaction to perform that conflicting operation. Timestamp based protocol always produce a complex serializable schedule, what we have already discussed, and the corresponding serial schedule of the complex serializable schedule will be from the oldest to the youngest schedule depending on the timestamp. So suppose if the transaction 1 having a greater timestamp than transaction 2 having a greater timestamp than transaction 3. So which one is the younger? TS is the youngest transaction of this schedule and T3 is the oldest transaction of the schedule. So the corresponding serial schedule for this schedule will be T3 followed by T2 followed by T1. But this is a very important point to understand the concept of the timestamp based protocol. If you remember this, each and every condition of timestamping will be very much easier for you to understand. The youngest, the oldest transaction will be executed first, then at the last, the youngest transaction will be executed depending on their timestamp, means when they are coming to the processor to be served. Now, how the timestamp based protocol going to control the conflicting operations that we are going to discuss right now. So first is the reading condition, when a transaction can perform a reading on a data item A. So let us assume Ti is the transaction requested a read operation on the data item A. Now we are dealing with conflicting operation. As we know that a read with a read never be a conflict operation, so we are not going to consider any condition where there are read and read operation. So when a read can conflict, a read can conflict only with the write operation of the other transaction. So the condition is based on the write operation or write timestamp of a data. Here we are seeing that the timestamp of transaction Pi is less than the write timestamp of the data item A. What does this actually mean? Means that the transaction I is the older transaction which want to write a data item A which is already written by a younger transaction. So in details in other words we can say that Ti requested to read a data item which is already written by a younger transaction, right? Now if that is true, then Ti is rolled back, so Ti will be rolled back and start with a new timestamp. And remember, this new timestamp will be always greater than the previous timestamp, older timestamp. Now why it is rolled back, we are going to explain that a little bit later. The other condition which is possible is that Ti is greater than the timestamp of transaction I is greater than equals to the write timestamp of the data item A, and Ti is requested a read operation on data item A. This means Ti requested to read a data item which is written by an older transaction. So if Ti is the younger transaction which want to read a data item written by an older transaction, we are going to allow the Ti to perform the read operation, and the timestamp of data item A will be modified using the maximum timestamp of these two, that is the current read timestamp of data item A or the timestamp of the transaction I. So let us verify these two conditions with some example. Now, here we are taking two transactions T5 and T10. Remember, this T5 and T10 is actually representing the timestamp. So 5 is less than 10. By this, we are assuming that it is the older transaction and it is the younger transaction for our discussion only. May not be the naming of may not be the same as actual one, but for our easier understanding, we are considering this one. The first condition is saying that the transaction I having lesser timestamp of the right timestamp of the data item A. So this means that the transaction 10, which is the younger transaction, have performed a data item or write on a data item A. That is why the WTS of A will be now 10. As we know that the right timestamp will be having the largest timestamp of the transaction. Then we are going to perform a read item. We are asking for a read operation on the data item A by the older transaction. In this case, we can say that the timestamp of transaction I is less than the timestamp of the right timestamp of the data item A. Now, as if you remember, the timestamp based protocol will produce a serial schedule which will be T5 followed by T10. So this thing cannot be allowed. As it cannot be allowed, then the T5 needs to be rolled back and it will start with a new timestamp. Right? Now, in this case, the second condition, what does it say? It says that the transaction Ti timestamp is greater than equals to. Now, equals to means there two process will have two transactions will have a unique timestamp. So equal means they are same transaction. So there will be no problem. There will be no conflict operation in the same transaction. Just remember this one. So we have directive only the greater than part. So as the timestamp of transaction I is greater than equals to right timestamp of the data item A. So what does this mean? This means that WA, the transaction T5 has performed the write operation on data item A. So in that case, the write timestamp of data item A is 5. Now, the transaction 10 is which have the transaction 10 having a timestamp of 10 is requested a read operation on the data item A. Now, as we know that the timestamp based protocol will produce a serial schedule which will allow T5 followed by T10, so there is no problem with this operation. So as there is no problem with this operation, we are going to allow the read operation on the data item A by the younger transaction. Now, here you can see that it is allowing dirty read problem. Now, as it is allowing dirty read problem, it will give me some problem in later stage. We are going to discuss that in later time. Now, next we are, so this is all about the reading condition when a read operation will be allowed in case of timestamp based protocol. Now, in case of write operation, remember write can produce conflict operation with read as well as write. So we have to consider all read timestamp as well as write timestamp when we are going to perform the write operation. So TI transaction requested a write operation on data item A. So we all need to check the read timestamp as well as the write timestamp of the data item A. So if TI timestamp of TI is less than the read timestamp of data item A, means TI producing a new value of data item A which should be produced earlier. We are coming to this point in a little bit later. So TI is rolled back and start with a new timestamp. So what is saying? It is saying that if TS TI is less than this, that time we are not going to allow the TI to perform the write operation. We are going to roll back. So what does this mean? This means transaction 10 has produced or already read the data item A. The transaction 10, which is the younger, the transaction already read the data item A. So our write timestamp of A for this one will be 10. Now the transaction 5 want to write the data item A. So here what is happening, as we already know that T5 should followed by T10, but here that condition is not satisfied. So we are not going to allow this operation and we are going to roll back that operation, roll back that transaction which is the older. In this case, the T5 is the older, so T5 will be rolled back and we start with a new timestamp. Now, so here you can see that how the write operation will be affected by the read operation on the data item. So what about the write operation? How the write operation will be affected by the other write operation? Suppose the transaction 10, which is the younger, has produced a result or written the data item A. Then the new transaction is requested to write the data item A. Now what is the T5 is the older one. So here what condition we are facing? We are facing that TS T5 is less than equals to write of transaction of the data item, write timestamp of the data item A, because it is 5 and it is 10, because the new younger transaction has produced that one. Now as this is true, and you can already verify that T5 should be followed by T10, as T5 this cannot be possible in this case, though transaction 5 or the older one need to be rolled back. So this is my second condition. If TI timestamp of TI is less than the write timestamp of the data item A, means TI requested to write the obsolete value or for data item A. So TI is rolled back and start with a new timestamp. Because the younger transaction has already written that data, and writing the value by the older transaction means I am writing a obsolete value, because the older transaction should perform the write operation earlier. So we are going to roll back that older transaction and we are going to restart that older with a new timestamp. Now the next condition says that if Ti greater than equals to, forget about the equals to, because equals to means both of the transaction is same. So if the timestamp of transaction I is greater than the write timestamp of data item A, or the timestamp of transaction I is greater than the read timestamp of the data item A, then Ti will be allowed to write that data item, and the new write timestamp for the data item will be the timestamp for the transaction I. So let us see that which two condition I am allowing to write. So first one, what does it say? It says that the transaction I having the greater timestamp than the write timestamp of the data item A. So that means the older process has written that data, then the younger process is going to write that data. So there is no problem with that one, because I am not hampering that the serial schedule will be T5 followed by T10. So I am going to allow that one. And now my write timestamp of data item A will be 10. That is the transaction which is producing the write operation on the data item A. Now next condition says that if the transaction T5 performing a read operation on the data item A, so read timestamp of data item A is 5, then the transaction 10 is requesting a write operation on the data item A. So here what condition will be satisfied? We are satisfying this condition. So as this condition is satisfied, means the older transaction has read the data which will be written by the newer transaction. So in that case, we are not hampering that serial schedule. So we are going to allow this one, and the write timestamp of the data item A will be 10. Remember, this is not like this. This is a separate case, and this is a separate case, a problematic operation. In this way, when a transaction want to perform the write operation, his timestamp will be checked with the other transaction timestamp, and if the condition is satisfied, if the last condition is satisfied, it will be allowed to write that data and the timestamp will be modified, otherwise it will not. Now let us see some properties of the timestamp based protocol. As we already know that it will allow conflict serializability, because it is not allowing the conflict operations to be performed depending on the timestamp. And as it is allowing conflict serializability, it is also allowing view serializability, because each and every conflict serial schedule is a view serial schedule. It ensures prevention from the deadlock, because we are not allowing any conflict operation and roll back that transaction which is going to cause problem, or in other words, the older transaction which is going to cause problem, then there is a preemption. So we are eliminating the condition of the deadlock, that is no preemption, and by eliminating that condition we are eliminating the chances of deadlock. But that doesn't mean that timestamp based protocol is the most powerful one, as it does not handle the dirty read problem, and it says nothing about when to perform the commit operation. This will lead to two different problems. One is when it is allowing dirty read problems, we can lead to the cascading rollback. Similarly, as it is not saying anything about when to perform the commit of the transaction, then it may lead to a non-recoverable schedule. The next problem is that it may suffer from starvation, as we are ending or we are hampering one of the transactions. It may lead to starvation of that transaction. And as we are going to check each and every condition while we are performing reading or writing operation, then it will take time. So this kind of timestamp based protocol make a transaction slow. These are the advantage and the disadvantage of timestamp based protocol. Now there is a slight modification in the timestamp based protocol, and that modification is done in case of the write operation. What is that? Now this condition is modified. Now in this case, instead of rollbacking the transaction I, we are just going to ignore the write request. So TI will not be rolled back, but we are not going to perform the requested write operation by the TI. And this modification is called the Thomas write rule. So modification in the of the timestamp based protocol in the writing condition. If TI wants to write the data item A and T timestamp of TI is less than the write timestamp of data item A, then instead of rolling back the transaction I, just ignore the write operation. So consider the schedule 1. If you are not considering the Thomas write rule, we are considering the pure timestamp based protocol. What is going to happen is that as the T1, T2 and T3, suppose this 1, 2 and 3 are actually my timestamps. So obviously T1 having a lesser timestamp than T2 and T2 is having lesser timestamp than T3. So as you can see that the transaction 2 has written a data, then the transaction 1 is trying to write that data. We are satisfying this condition, and as we are satisfying this condition, pure timestamp based protocol says that I need to roll back the transaction 1. The Thomas write rule, it says that if this condition is true, then instead of rolling back the transaction, that is, we are not going to roll back the transaction 1, we are going to ignore that write operation. So that is how the transaction 1 will not be rolled back, and that is how the Thomas write rule works. Now let us discuss this schedule 11. If we use timestamp based protocol, then we are going to roll back the transaction 1. Now let us take the schedule 1. If we draw the precedence graph, there will be 3 nodes where there will be a edge from transaction 1 to transaction 2 because of these two conflicting operation, and there will be a edge from transaction 2 to transaction 1 because of these two conflicting operations. Now as there is a cycle in the precedence graph, we can surely say that it is not a conflict serializable schedule. But the schedule 11, we have already discussed that is a view serializable schedule. And from here we can say that the Thomas write rule, we are allowing the view serializable schedule. So this is all about this is the property of the Thomas write rule, and you can also see that there is nothing to deal with the dirty read problem, so it may suffer from cascading rollback. There is nothing said about the commit statement, so there is a possibility of non-recoverable schedules. It may suffer from starvation, but it ensures that there will be no deadlock, and as it is producing a view serializable schedule, so the schedule will be consistent. So that is all about the timestamp based protocol for concurrency control. In the next set of video lectures, we are going to discuss about the recoverability or the recovery management system of the database management system. So thank you, stay safe, and see you in the next lecture.